Let's look at problem number 1 from ISI 2021. Okay, so ISI 2021 PEB part. So in question number 1, as you can see, we have to prove that okay, so we are given this function R2R. So f is a real valued function such that it has 3 roots. Right, so it's a continuously differentiable function, so it has 3 roots. We have to show that another function g, which is again R2R and defined as g of x is equals to e to power x by 2 f of x, also has 3 roots. Now as you can see, this part e to power x by 2 is always positive, right? So this part e to power x by 2 is always positive. So what we can say is g of x is equals to 0 if and only if f of x is equals to 0. So this implies that g of x has exactly 3 roots, because there is no other possibility for g of x to be 0. Okay, now let's look at problem number the second part of this problem. We have to show that the function f plus twice f prime, it has at least 2 distinct zeros. Okay, so it should also have at least 3 distinct zeros. Oh sorry, I made a mistake in first part. So it has not 3 roots, it has at least 3 roots. So g of x will also have at least 3 roots. The number of roots of g of x will be exactly equal to the number of roots of f of x. Anyway, coming to the second part, we have this function. So let's look at this function. Let's start with looking at my g of x. Okay, so here's the trick of doing this part. So you differentiate g of x. So what we get is g prime of x is equals to half e to power x by 2 f of x plus e to power x by 2 f prime of x, which is basically e to power x by 2 upon 2 into f of x plus twice f prime of x. So this is my g prime of x. Now what I know is that as g of x has 3 roots, g prime of x is equals to 0 at least twice. This is directly an application of mean value theorem. So if you want to look at a graphical proof of this, what we are saying is that g of x is some function which has 3 roots, right? So maybe g of x, it looks like this. Okay, so these are my 3 roots, x1, x2, x3. Now what mean value theorem says is that if x1 and x2 are roots, then between x1 and x2 there will be a point y1 such that g prime of y1 will be equal to 0, and again there will be a point here where g prime of y2 will be equal to 0. So if a function has 3 zeros, its differentiation will have at least 2 zeros. So that comes from the mean value theorem. So this is direct application. Now coming back, I have shown that g prime of x has at least 2 roots. So what I have now is that g prime of x, which is e to power x by 2 upon 2 into f of x plus twice f prime of x, has at least 3 roots, has at least 2 roots. Okay, now again what you can see is that this part is always positive. So g prime of x will be 0 if and only if f of x plus twice f prime of x is equals to 0. So if g prime has 2 roots, Okay, so if this thing has two roots, it automatically implies that this thing will also have two.